Are we ready to get started?
Yeah, I started recording on mine.
Okay, great. Looks like we have some folks in. So yeah, did you guys want to do an introduction or anything, or just get rolling?
If you could, Josh, since we are going to record it and put it on YouTube, if you could do a quick introduction of like kind of your background, I think that would help folks before you get started.
Oh yeah, that's actually in my first slide. So
perfect.
Okay, well, let's go ahead and get started since we're a couple minutes after. Thanks everyone for your patience while we sorted out the technical details. Always the fun part with mics and screen sharing and recording. But this is going to be a talk on Git and GitHub, version control for the Unversed. So this is going to be a gentle introduction to Git and GitHub technology. For coders, for folks that want to do documentation, folks that want to share media. This isn't just for software developers, it's for folks that want to contribute to any kind of open source or Creative Commons projects that use Git. So, in terms of my background, what I do is I'm a software engineer at Microsoft day by day. I work on a cloud storage product called Azure Managed Lustre. I do a lot of Python development in particular, and am interested in learning everything I can. But what brings me here is my tech education project, chaintuts. I create free and open source content about cybersecurity, cryptography, digital currencies, and computer science topics. That's really my big passion outside of being a software engineer, is also sharing that with others and, hopefully providing useful learning materials. I also volunteer at the Cryptocurrency Certification Consortium, known as C4. Doing very similar work, creating educational content focused on security, how cryptocurrencies work, and really helping anybody that's interested in learning about it and isn't sure where to start. Outside of work, I'm really active. I like to climb, do jujitsu, hang out with my wife and our cats, and just get my hands on a little bit of everything. I like to tinker. So let's talk a little bit about version control. So what is Git? Why do we need it? Why is it useful? What Git really is as a version control software is it allows the users to track changes to especially textual data. Git is primarily focused on storing and tracking changes to text. You can use it with media like images and those sorts of things, but it's not really designed for big media like large volumes of photos or videos or that sort of thing. What it's really good at is text. And when I say text, that could be anything from obviously source code. It could be documentation. It could be articles. You could use it for a blog. Anything with storing text data. And Git is useful for everything from one-person personal projects all the way up to enterprise software where, as much as 50 plus engineers are working on the same code base. I use Git for my solo projects for chaintuts. I store my code demos and my articles and my slide decks using Git. And I use it every day at work. So I work with a team of 15 to 20 engineers, and we all coordinate using Git. We use a different hosting platform called Azure DevOps for work, but it's the same underlying software. So why Git versus other types of version control software? Well, Git allows users to store distributed copies of the code without updating the server. which is really useful, especially in the context of open source. So some other version control that exists, like Subversion and other ones, usually require you to be connected to the main server. And anytime you make a change, even if it's on your own branch, it has to sync with that external server. What's really nice about Git is anybody can make a complete copy of the code from the server, like GitHub or from ADO or any other server that's storing the code. So you can work on it independently, and then you can coordinate pushing back those changes. This makes it really useful for things like open source projects, because people all over the world can have a copy of it, work independently on different features, experiment, tinker, without having to really coordinate the direct access to that code on a server, and you can push back and make your changes. So let's talk a little bit about Git versus GitHub. Sometimes folks don't know the distinction, and it can be a little bit confusing because GitHub is so popular that a lot of people think that they're one and the same, but they're actually two slightly different things. So Git is the software itself that you use for version control. Git itself is an open source project. Anybody can download, modify, and share the Git software, and it's very, very common. You can run it on Linux, Windows, Mac, anywhere you can install Git, you can use it. And in terms of running a server to coordinate changes between multiple people, anybody can run a Git server that you could connect to. You don't have to use GitHub, or you don't have to use Azure DevOps. What GitHub is really just Git as a service in a nice package. It allows the convenient use of Git, convenient storage, backups, sharing, and collaboration. GitHub is really popular because it makes all of that work of sharing your code, coordinating with others, really, really easy in a nice web platform. So, I like to say, just try to come up with a couple analogies for this, right? Git is to GitHub as food is to a restaurant, right? A restaurant is just food as a service. Git is to GitHub as rock climbing is to a climbing gym. A climbing gym is just a really nice service where you can go and rock climb without having to worry about the weather, setting up your own gear, and all those sorts of things. So it's just rock climbing as a service. So let's talk a little bit about Git workflows. So I'm going to talk about sort of two different approaches to using Git, and there's many, many different approaches, but in the context of this talk, I want to talk about kind of the really basic workflow, which is using Git for your own personal projects, and using that to really just track changes and share and store when you have one developer or maybe two. And then sort of the more complex workflow, which is what you see with popular open source projects or professional development like I do for work, where instead of just having a single branch and we add commits to that branch, which are distinct code changes, we have a main branch, we have multiple branches where we work on our features, and we coordinate what changes get into sort of the main line code through pull requests or merges. I know a lot of that terminology is fuzzy right now, and that's okay. We're going to get more into what all of that actually means. So first, let's talk about the basic level, which is using Git for a single local repository to track your own text, your own code, your own changes. There are several commands that are basic and useful when we talk about using Git. By the way, I should say, my experience with Git as a software developer is almost exclusively with using the command line. I do believe there are some nice, user interfaces that wrap some of this Git logic if you're somebody that likes to point and click and work with it that way. I'm just going to be talking about command line Git commands because that's what I know, that's what I understand, and therefore I can talk about intelligently for you all. So this is kind of assuming that you have Git installed on your computer and you have a command line emulator. So if you're on Windows, maybe you're using just CMD or you're using conemu. You could be using a terminal emulator on Linux or Mac or anything like that.
Hey, Josh, can I ask a quick question?
Yeah, sure.
So if you, let's say you've got a GitHub account, is that automatic? This might be a dumb question. Is that automatically install Git, or do you have to do something separate if you have a GitHub account?
So that's a good question. If you have a GitHub account that does not install Git locally on your computer, so generally speaking, there's going to be two parts to interacting with GitHub, and I am going to touch a little bit more on that later. There's the actual GitHub stuff, and then there's the local on your computer stuff. So you would still need to independently install the Git software on your computer if you want to use it this way. But again, it's open source. It's freely available. You don't have to pay or anything. You don't have to have any sort of account, even like GitHub, to use Git itself. You can just go to the main Git website and download it, and find the installer for your operating system of choice. That's a great question. So when we talk about some basic commands here, again, assuming you have a command line up and you have some basic familiarity with that, the first command that you'll need to know is git init. And this takes a folder, the current directory that you're in. So let's say you have a folder that contains all of your code or all of your documentation, and it turns it into a Git repository, which essentially means like now the GitHub software is going to start tracking the files and the changes to those files in that folder. Git remote add with a URL is how you would connect your local copy of your code in your Git repo to something like GitHub. So when you create a repository on your local computer and you start tracking your changes, and you want to push those changes to your GitHub account, your GitHub account will give you a URL when you create a new repository. So let's say, I have a theoretical repository called the DigiByte docs, where I'm, documenting how to use DigiByte for a first-time user. You could create that repo on your GitHub account, and you would create the repo on your computer, and you would give that repo the URL that GitHub gives you. So now those two can start talking to each other. Now, if you already have an existing repository on something like GitHub, and you don't have the changes locally yet, you would instead use something called git clone. So this takes a URL, again, like a URL that GitHub gives you, and creates a local copy of it on your laptop or your PC, your machine that you're running Git on. So this is an easy way to coordinate with a server. Like say you want to contribute to DigiByte's main node software. You could git clone that repository locally and then start tinkering with the code. So now that you have a local copy and you have a server copy, how do those two talk to each other? Like I said earlier, the unique thing about Git is you can do whatever you want with your local copy without it immediately having to sync with a remote server. So Git uses the concept of push and pull. So if you want to push your changes to a remote repository that you have permission to, you would use the git push command with the remote name. So, for example, you might call your remote repo origin or chaintuts or something like that. And the branch name, which for the start of this talk, we're just going to assume is main, like the main branch. Now, let's say you have a friend that's also working on changes to that repository on GitHub, and you want to pull all of their changes into your local copy. you would do the opposite command, which is git pull. So you would git pull origin and main, say, to pull all the main changes into your local main branch. So that's at kind of the repository level. But how do we actually add our files and track changes to our files? So we do this with the git add command. And this is really important to know. When you initialize a Git repository in a given folder, say your local DigiByte docs folder, it doesn't automatically just start tracking all of the files within that folder. You can have files that are what we call untracked, that live in that folder, but that Git doesn't have any knowledge of yet. Anytime we make changes and we want Git to be aware of that, we use the git add command. So let's say, for example, I just started my DigiByte docs repository. I have 3 text files in there that I'm going to push. I need to do git add and the file name to let Git know I want you to track this file and I want you to track any changes to this file. You can also use the handy shortcut git add dot, and that will automatically recursively add all the files in that folder to Git tracking. So this is really useful if you're spinning up a brand new repository and you have, say, 10, 15 files you want to track, or 20 files or 30 files, right? You don't want to have to manually type every file name, so you can just say git add dot. But you have to be careful with that because there might be files in there that you don't want to track. Without getting too technical, where many developers get into trouble with this is accidentally committing files that contain cryptographic secrets like passwords or keys. And once you add something like that to a Git repo, they're really hard to scrub, and that usually means that somebody has to have a bad weekend rotating all of their passwords and keys. So, just to be aware, if you're doing stuff with code and you're storing things like API keys, be careful what you git add to your repo. The opposite command would be git rm, which removes a file both from Git and locally from the folder. So that's like, oh, I changed the file, I want to delete it, I don't need this file anymore or this code. You could git rm. And at every point when we create a set of changes, like the initial release or subsequent feature changes, we do what's called a git commit. And this is sort of the distinct unit of Git that's really useful to know about besides branches, which is every branch has a series of commits that track the changes between files as we go along. So let's say I already have an initial commit with my 3 documentation files, and I want to add a 4th documentation file. I would git add that 4th file, and I would do another git commit with a message like added new file on how to generate DigiByte addresses. And I commit that, and now there's 2 commits in my branch. The initial release of the first 3, and a commit containing that change to add the 4th file. Is everything making fair sense so far? Folks have any questions on what we've covered? We can also save it for the end, too. Great. So let's talk about then, using these commands, what a simple workflow looks like for a personal GitHub account. So this example is something that I do very regularly because I push a lot of articles and I push a lot of educational demos of code, like my personal portfolio, to my chaintuts GitHub account. So let's say I have a new project, a new code demo that does something really fun. First, I'm going to create that new repository in my GitHub account. So GitHub has a nice point and click workflow for creating a new repository, adding a description, and all those sorts of things. and that will give me a URL. And if you're not familiar with that term, a URL is just a web address, like google.com is a URL. But GitHub will give you a URL that's something like github.com/username/repo.git. So for example, github.com/chaintuts/addervalid is going to be one of the demos that you'll see towards the end of this talk. So on our local copy, where we have all of our code, we'll do git init and git branch -m, and then you can name your branch whenever you want. I just do this because I like to name my main branch development. You can name it main, you can name it anything you want. Next, I do git add dot. So this will add all of the files in my code folder recursively. And when I say recursively, I just mean if you have subfolders within your Git folder and you do a git add dot, it will also add all of the files in those other folders. So you might have a source code directory, you might have a tests directory, you might have a documentation directory, or like a resource directory with text files and useful data for your project. If you do a git add dot at the top of the folder structure, it'll add all of those files and folders for you. And again, like I said, disclaimer, be careful with that. There's another concept called a .gitignore file that's useful, which can tell Git that even when you do git add dot, it'll ignore certain files that you want it to. Most commonly, this is used for things like compiled source code. So, you know, if you're building code in a language that compiles, or even an interpreted language, and you like have a make script that puts everything in a bin folder, so you can run the code, you usually don't want to push those copies to Git because those can be big binary files, executables, you know, weird folder structures to get your code to work. And Gitignore is really useful for that because there's some stuff that doesn't need to be in the main open source repository. And then we would do our git commit with a message. I usually do just initial commit for a project. Now we want to get our local repo talking to the GitHub repo. So we'll do our git remote add, and then you can call it like origin. I think that's the default. You could call it your username, like you could do git remote add chaintuts, and then you paste in that URL that GitHub gave you. And finally, you do a git push. So you'll push to that remote name and the branch name. So in this case, it would be something like git push chaintuts development. So at the end of that, what you end up with is you have a local copy of your code or your documentation or whatever you're sharing, and all of those code changes are now tracked in your GitHub account as well. So if you navigate to your GitHub account and your repo of choice, you'll see all your files in there, and you'll see your list of commits and all of the changes that you've made. So this is how you can take a repository that you are keeping locally, your code, your changes, and share it with the world on GitHub, or share it with yourself on GitHub if you're using private repositories. And you can have a useful backup, you can have access to the collaboration tools and all of those things that GitHub offers. So let's talk a little bit about Git branches, because this is an important concept that's more important in the context of open source or professional development generally than it is with sort of your individual portfolio projects. Individuals can use multiple branches too. It just depends on how you want to organize your code and your changes. You know, even at a basic level, you might want to have a development branch that contains all the commits and, you know, all of the features and bug fixes that you're doing, and then have a release branch with very distinct bundled up commits that are your releases that are like kind of a little more refined. But you know, a lot of developers, especially for educational projects, you're probably just going to have a main single branch. But that's not the case with open source and with professional development. We need to be able, when we're coordinating with lots of people, to coordinate changes in an efficient and sane and sort of clean way. Because we don't want, if we have 50 engineers contributing to a project, every single person to push their commits to the main branch right away because somebody might introduce a bug by accident. There may be legal requirements. There may be contribution requirements. We need to have some way for people to make proposed changes and then review those changes before we get them into the main source of truth. This is important for security reasons as well, right? You wouldn't want anybody to just be able to push to your main branch, especially with cryptocurrency software, because somebody could introduce something malicious. So, the git branch command will show you the current branch in a list of branches that are available for this particular repository. So, for example, you might have a main branch that contains releases, you might have a development branch, or you might have individual branches created to work on a specific feature. Like, let's say you have a DigiByte wallet that you work on, and you're working to add new address formats or something like that. Because I know DigiByte, like Bitcoin and Litecoin and others, has a few different address formats. You could have your own branch called like new addresses on the side where you're working on that feature without it interfering with the main branch until it's ready. So git checkout-b branch name creates a new branch using the current branch as a base. So oftentimes, for example, again, using this feature example, you want to start with all of the commits that are in main, which is the latest stable source of truth for the code, and you create a new feature branch off of that you can work on your own code independently, and then pull it back into the main branch eventually. Git in general uses this concept of branches very heavily. So it's this great way to independently track these changes, and then you can pull one branch into another, doing what we call a merge, or in GitHub and Azure DevOps parlance, do a pull request. So I created this little diagram. It's not the most elegant one in the world, but it kind of shows the general concept of Git branches and commits and how they relate to one another. So here, each of these squares represents an individual commit, an individual change to the files that are in that Git repo. We have our main branch, and let's say that again is our main branch, right? That's where we get all of our stable new features and bug fixes in. We create our releases off of. So if it's something like a wallet software, maybe every 3 months you use the main branch and you create a release and you package up the software and send it off to Google Play and iOS and PC versions and all of that. But we want to be able to work on features and bug fixes without initially pushing all those commits to the main branch until they're tested, or they're reviewed, or they meet whatever contribution requirements this particular project has. So for example here, as you can kind of see in the diagram, at our second commit, we want to add a new feature, so we create the feature1 branch. And off on the side, we add another commit to add this new feature, like allowing our wallet to generate a new DigiByte address format. Now, using GitHub terminology, what you would do is you would create a pull request, which is a request for the folks that own the repo and have access to review your code changes on the feature1 branch, and then pull those commits, it could be one or it could be many commits, back into the main branch. So in this case, let's say we add one commit to add this feature and the pull request gets approved. So now that third commit in our line here is that commit off of feature1, and it's now in the main branch. Let's say that change introduced a bug. Not that uncommon in the software world. I've done it many times, both professionally and with my own projects. Software development is hard and bugs happen. So now we create a bug fix one branch off of main, and we do another commit which fixes the problem, and we do a pull request to get that into main. So this diagram with the arrows just shows a simplified view of how this branch pull request workflow kind of operates. Right, like whatever our project is has a main branch, and then we can do these features and change things, and have some testing. Like, for example, you might have to have test packs before you can pull it into main. You might just have to have a more knowledgeable person review your code. That's all part of it when it comes to both open source and professional development. So, specifically, let's talk about contributing to a open source GitHub project. This can even come in handy if you have, like a GitHub organization. Like, let's say you have your main portfolio and then you have like some showcase ones, or you belong to an organization like a DigiByte organization, and you want to be able to coordinate changes between them. So in the GitHub world, what we do when we want to work off of an existing repo and create our own changes is we use the fork feature. So, I have a GitHub account called @chaintuts, and let's say I want to contribute to a particular DigiByte code project. I would go to the DigiByte page and create a fork of that code base that will be owned under my account. So let's just say, hypothetically, it's DGB/wallet. Now I'll have a copy of that code called chaintuts/wallet. You can either use your own main branch or a feature branch on your repo, however you want to, and make your own changes. So you do git add and you git commit your contribution. Now, you create a pull request to the target repo and branch. So I would navigate to the DGB/wallet page and click create a pull request. GitHub will sense that I have a compatible repo that's a fork of that one called chaintuts/DGB, and it'll sort of present some options based on what's different in my repo than the main one. Like, I have another feature branch to add new wallet features, and it'll be something like, pull chaintuts/DGB/new wallet feature into DGB/wallet/main. Right, these are all hypothetical branch names. And this is something that you can play around with a little bit more in the UI. It makes it helpful. Or, if you say have two copies of a code repo, like you have a main and you have a sort of like a portfolio showcase or an organization that you share code with, you can use pull requests to synchronize changes between the two. Like, maybe I push to my main account, and then I eventually pull those changes into the organization one. So that's a useful workflow as well. Now, somebody on the main repo, DGB/wallet, has to approve that change based on their ownership and whatever what we would call gates they want it to follow. Like, maybe your change has to pass a particular series of automated tests. Or maybe it just has to go and the guru of that repo has to review it and say it's good to go. But when somebody clicks complete pull request, it will merge the changes from your branch into that main branch. So this is the kind of workflow that you're likely going to see if you're following this talk because you want to contribute to open source. So you're going to be able to create forks of repositories, and you're going to be able to create pull requests and then have sort of the main people that own that open source repo approve your changes. So how about a real example, right? This is a lot of technical talk. This is a lot of command line stuff. I realize this is a fairly large volume of information. I'm of the opinion, at least me personally, I learn by reading, but I also learn a lot by tinkering. And for me, having a concrete example to work with can really help me actually figure out these concepts. If you're a little bit confused by all this information, that's okay. I hope I've been clear, but it's a, 20, 30-minute brain dump here of a lot of info. So let's talk about some ways you can learn through experience with Git. Well, the first example, if you've never used Git and GitHub before, is to just create your own repo for something basic. None of this requires that you have to even learn how to code or write software or contribute to other people's software. Git is most commonly talked about in terms of code because it's extremely useful for coordinating code changes. That said, Git is also for folks that write documentation about software. You could use it for art. You could use it for blog posts or articles, and that's something that I do as well. So maybe you just have a couple, bits of poetry you've written on your computer, or maybe you're writing a book, or maybe you're trying to write some documentation about how to use your favorite DigiByte wallet because there are no docs yet. You can create a repo on your computer, create one on your GitHub account, and do that first basic workflow that we talked about, which is you add code to your main branch and you push it to your account, and you can see it there. Oh, my code's in GitHub now. You could also contribute to an existing open source project. Maybe you have a particular piece of DigiByte documentation or software or community media that you're very passionate about, and you want to learn how to, add some value to that. You can do that. But that said, of course I wouldn't come to a talk on Git without a concrete example and a simple example that anybody could come and hopefully learn something from. So this week, as I was preparing this talk, I created a very simple code repo that is on my GitHub account called addervalid. And all this is a very simple Python code script that takes a DigiByte address, a legacy DigiByte address, and validates it. Like, it looks at a string and says, is this a valid DigiByte address or is it not? And I wanted folks to be able to try this workflow out without having to know anything about code. So within my repo, there is a test/res folder, and there's text files in there. And each file is literally just a .text file that you can create with Notepad on Windows or any other basic text editor of choice. And my test code just reads through all of those files and test them to see if they're valid DigiByte addresses. So, if you don't know how to code and you really want to try this workflow of contributing to somebody else's open source repo, and you don't want to have to learn how to code or go through something really complicated, you can clone this repository, create a fork, add a new text file with a valid legacy DigiByte address. That's all you have to do, and submit a request against it. You can also add an invalid address if you want, and that will get my butt into gear into adding code and tests for testing invalid addresses. If you happen to know how to code, but you've never done a pull request, you can also make some changes to my Python code, and as long as it works, I'll take a look and approve it. So this repo is just a little test demo that's something fun and something we all care about here, which is DigiByte. So if you're interested and you want to try that out, please feel free to create pull requests against that repo. I don't know how quick I'll get to it, but I'll try to keep an eye on it and let folks contribute. So I believe that is all that I had in terms of all the technical talk. So I want to do a Q&A, and then I'll end with some contact info from me, where you can find me, where you can ask if you have additional questions. So let's open the floor. Does anybody have questions about how all this works?
I have a quick question, because you're kind of you're involved with a lot of different projects. are there any like public projects? Obviously, you're on private projects too. Any public projects that you're like, these are good examples of like a well-functioning GitHub process or GitHub community for this? Like, do you have any that you're like, wow, that one, like, this was really well done, really well organized? I'm just curious.
That is a good question. Off the top of my head, because I spend so much time creating these demos and things, I don't have a ton of time to really contribute to other projects. I have done some work with a website project called Accept Bitcoin Cash, because that's another crypto that I'm passionate about, that I like. And that's one that folks could contribute to. You don't necessarily have to be technical. It's more like editing configuration files and that sort of thing. The Linux kernel is a really popular example. That's one where lots of folks try to contribute to it, but there's a pretty high bar for quality and entry to actually be able to do anything. So, that's kind of an example of one where it's like you probably wouldn't want to start with that, but it's a very good example of a popular open source project. So I'm sorry I don't have a better answer there, but
no, that makes sense to me. And because we're trying to, like, just in general, put everything to move through GitHub, like whether it's the website or not just the code, but the information infrastructure of the network, and pushing everything through that. So I was just wondering if you saw that with other projects, so maybe it's something that we can look at for ourselves. But you answered it for sure.
And I would say too, if this helps, if you're trying to get more of the community and community projects on GitHub, there's so many examples out there of projects that they're good projects that you could look for that I couldn't name off the top of my head. But kind of some general rules of thumb to keep in mind is really you want to have a document in your repository that states what the contribution guidelines are. That's a big one, because if you have new people coming into a project, you want to have a solid, easily accessible document that states basically what the rules are, right? Every project is going to have different rules for what gets pulled in, what doesn't, what the code of conduct is, all of those sorts of things, what the basic workflow is like. Like, you must create a feature branch with feature name, or, you can use this specific testing branch and it has to pass a certain series of tests to get into main. Adding automated testing is really, really helpful for software. That's pretty important, especially for open source. A lot of that comes down to the details of the individual project at hand, but that would kind of be the biggest thing I would focus on is make sure that you have a document that states how do I contribute to this, what are the rules, and what you want to give new people a roadmap for how they can do things the way that you want them to.
Hey Josh, this is Jose. I got a question. So back a few months, I thought I'd give it a try, and I started looking up tutorials on YouTube, simple, basic tutorials. And I've gotten to the place where I can do I've done code edits with the GitHub code editor, but not with a specifically downloaded software. So would you recommend a certain type of software for code editing and or any tutorials to do that?
Oh, that is definitely a really good question. So it's going to depend on the language and also your level of comfort using the language tools. So what I mean by that is, let's just say, for example, I do a lot of work in Python. So, you could use something like Visual Studio Code with the Python plugin for that. And that's going to help you with all of your syntax highlighting, making sure things are valid syntax, an easy way for you to run and execute that code. Because a lot of what makes your life easier is, you might be able to do a one-line change in the GitHub code editor, but can you run the software and actually manually test that your code changes is behaving as expected. I will say, me personally, and this is somewhat common in the professional world, about half of us use these advanced code editors that have the syntax highlighting and the features, and then the other half of us just use a basic text editor and then just go run the code. I'm more the second type. I use Vim, which is a command line code editor. I've used Nano in the past. I use Notepad++ on Windows, where it's literally just a text editor that maybe does some basic syntax highlighting, and then I have my command line open where I can actually run the code or build the code, that sort of thing. That kind of depends on what you're doing. For me, like developing a Python project that's command line or a basic UI, I'm just using a text editor and using the Python command line. But if you're doing something like building an Android application, for example, that's very complex. There's a lot of libraries and build rules that go into that. So for that, I use Android Studio. Right? If I'm building a microcontroller project using MicroPython or Arduino, I use Mu for CircuitPython or the Arduino IDE. So I know that's a long answer, but basically it's going to depend on the project and what are the languages and tools you're using. But I mean, honestly, for a lot of us, it's just a text editor and a command line window. So if you know what language you're using, I might be able to give better recommendations.
Or response, I think. I started identifying issues on our website, and the website's JavaScript, CSS, and HTML. And then after a while, I think somebody invited me to okay, you're gonna, request changes or improvements to the website, but here, help by reviewing it. And then, so I would review it, look at, the changes. I could see the changes, but I just couldn't figure, and you mentioned it, to be able to test it, to look at, after somebody changes the code and what that looks like. And so that was going to be my, my next question about being able to test. But I think that you kind of hit on that. You just, you need to have the text editor for that code, and now you should be able to run the test, right?
Yeah, so generally speaking, that would be the idea of doing the git clone. So you would clone the repository from GitHub onto your local computer, your laptop or your desktop PC, and then you can install whatever software you need to run it. So if it's a really simple website that uses just standard JavaScript HTML, you can just clone that code and then open up the HTML files in your normal web browser, like Google Chrome. If it's something more complicated, like a Node.js app or something like that, then you would need the NPM tools and all those sorts of things. Or like I said, if it's an Android app, you would probably need Android Studio to be able to efficiently build, run, and test the code. So yeah, I hate to give the typical software engineer answer of it depends, but it depends. It depends on what you're working on and what the tools are.
Thank you, guys.
Yeah, thank you. Great question.
Hey Josh, thanks for the presentation. It was really good, and I appreciate the technical parts of it, especially because I think there's a lot of confusion about Git and GitHub, especially in the community, with people who come in and want to contribute, but I feel like they, and me to an extent included, like it feels like you hit a wall when you want to make an actual contribution. So how can you could you just give like the most explain like I'm 5 answer about what Git is in GitHub? Because when you're actually using it, it's mostly just file explorer and command line, right? Is that the gist of it?
Yeah, pretty much. Like, 99% of my interaction with Git itself is using the command line. And then I use GitHub to create the repo and copy that URL and put it into the Git remote add so I can push changes. I personally haven't really made much use of features like the GitHub code editor itself, just because because I am a professional software engineer, I'm used to doing things locally and building and testing. But there are other ways to go about it. So like what I'm presenting today is sort of the fairly technical, but also fairly straightforward way to do things. But there's probably, useful Git UIs and the GitHub tools that could make this even easier as well. Did that answer your question, or did I go off?
Oh no, yeah, that's what I was trying to get at. And also one more question about something that's kind of similar to or a sister topic, and it's about the decentralization aspect of Git and how GitHub plays into that. A lot of these, like DigiByte is a decentralized cryptocurrency, but we're relying on GitHub quite a bit. And some people have spoken to how it's not too much of an issue. What's your perspective on that?
I mean, I think the idea that you should have multiple redundant copies of a project is probably somewhat of a good idea if it is a decentralized technology, especially. I can think of an example of this. There's a very popular bit of open source software called YouTube DL, which allowed users to feed YouTube video URLs to a command line tool, and it would pull them off of YouTube so you could like download a video or download a soundbite from YouTube. And, this is a pretty agnostic piece of code that just gets data off of a public website. But because of copyright rules and things, that repository, I believe, was taken off of GitHub because like Microsoft and GitHub were just getting too many complaints about it. So, for that project to continue, I don't remember what they specifically did, but they might have to do something like run their own GitLab server. There are tools on top of vanilla Git that allow you to basically run your own GitHub-like platform. I believe GitLab is one of them. And I've tinkered with some other ones that I can't remember the name of. But like, GitHub is great because it's popular. You can get a lot of people to contribute there. But you may also want to have like, hey, I'm a person that knows how to run a server, and I'm going to run a mirror copy of this DigiByte main wallet, main node software. So if for some reason, the GitHub repo goes down, we have a backup somewhere. And two, in a way, like I wouldn't say this is the best public backup, but everybody that clones your repo and keeps it up to date also has a decentralized copy of the code. So, I think it depends on the project. I mean, I don't think that most crypto repos are going to run into major issues, but I mean, like we saw what happened with the Tornado Cash developers. We've seen what happened with YouTube DL. It's not the worst idea to run your own Git instances if you feel like your project might run afoul of someone somewhere. And it's really easy to do. Because Git is decentralized by nature, you don't really have to do anything special to like run your own instance of it.
All right, man. I appreciate it. Thank you.
Thank you all. Anybody else have any live questions? Cool. So, the last fun part. First of all, I want to thank you all again for having me. I genuinely love doing this. I love talking to people about technology that I'm interested in. So I'm really excited to be here. Made an extra fun way to spend my Sunday afternoon. And, outside of the live questions here, I try to make myself as available as possible when folks have questions about the tech that I know. So you can find my stuff at chaintuts.com, github.com/chaintuts, which includes that demo repo if folks want to try a contribution. I'm on YouTube, youtube.com/c/chaintuts. And I'm all over social media, Twitter, Instagram, Facebook, LinkedIn. Usually, I think just chaintuts is the handle. Of course, beware of imposters. I don't think I'm important enough for people to impersonate me, but I've seen it with everybody that I've met in crypto. So, I have a contact form directly on my website, chaintuts.com, too. So you're getting me if you have a really sensitive question. So please do reach out, share, ask me questions. I'll absolutely do my best, even if I'm not an expert. Happy to help. So thank you all again.
Thank you so much, Josh. This was awesome. And as always, you did such an amazing job. So, and then we'll have this recording. I think you and Archie are both recording this.
Yes.
So you will definitely have a recording. We'll have, make sure we'll get that out on socials for that. But thank you for taking your Sunday for us.
Yeah, thank you for having me. This was a blast. And like I said, if anybody has any more questions or you're a little confused, please feel free to reach out. I'll do my best.
Sounds good.
All right. Thanks again. Yeah. All right. I'm right at the 3 o'clock mark. So I'm going ahead and stop recording. Thank you so much for coming in. It was really a great talk.
Yeah, thank you all. Thank you very much. And I'll probably post the recording. I want to make sure everything went smooth, and I'll reach out to you, Archie, if I have any issues and need your recording. So.
Okay. Yeah. No, it's always good to have the redundance. So we got it. All right. Take care, everyone.
All right.
Bye.
Bye now.